So I wanted to do a follow-up on this escapement meter because in my last video, which was all silent, I thought it was interesting just to show its use and let you kind of understand how it works. And I think that that works for the most part, but but there's some really cool things about it that I didn't go into because that video I was just using it to measure the pallet stone distance to see if those pallet forks I was comparing were consistent. So the thing that got me interested in the escapement meter was this guy, Bob Inchak, he's an American who was trained in watchmaking in around 2017, 2018. And I discovered his website. And what's interesting is that the escapement meter, and it's true of the one that I have too, it's also true of these micrometers that you see that are I hate not remembering how to pronounce things, but it's like J.K. Fenmeister, I don't know. Anyway, the micrometers that also have this kind of spring-driven sensitivity, the spring is actually either a hairspring or a mainspring from a watch, probably a hairspring, and then almost certainly a hairspring. A mainspring would be too powerful. And the hairspring is driving the thing to a point well, let me back up on that. I don't know exactly what it's doing, but it's using watch movement gears, which you can see here, to change the gear ratio to get that hundredths of a millimeter out of a very small movement of the measuring device on the tip of the micrometer. So you're doing this double geared, in each case you're going from a large wheel to a small pinion twice probably, so you're getting this huge magnification of the rotation. And then in the end it's connected to the thing that's driving the measuring, this point right here. But so that's what's inside there, and that's why these things, you can tell when you see it used, you can tell it's spring-driven. It's spring-driven back to the outward position, I guess, and then you drive it forward mechanically, and then they don't break because there's some kind of spring also in the device that keeps it from, so your pressure is not direct. Your pressure is, I should take it apart and figure out exactly how it works, but this is interesting enough for now. Okay, so then the other thing about them, though, is that it requires a heater. So, like I said, I bought the one that I got a couple weeks ago in Zurich, and then I went on Ricardo and I saw that there was somebody was selling a heater for 38 francs. And this is the purpose-built heater. I repainted it, yeah, so I was like, well, I can't pass that up because it's kind of purpose-built and they probably don't come on the market every day. So what I'm going to do in this video is use the escapement meter in its hot condition, meaning it's heating up right now, and I'm going to try to remove a pallet jewel from this tiny pallet fork and then put it back and re-shellac it. So I have some shellac here that came with some lot of parts that I bought. I have a little swab to try to clean it up with while it's hot. I have a heat gun for soldering that is precision controlled. And then I have a couple of digital thermometers to check the temperatures of everything. So shellac melts at 167 degrees Fahrenheit, which is 75 degrees Celsius. And I guess I'm worried I'm going to burn myself because for obvious reasons. But I actually, 175 or 75 is not that hot. Certainly you can burn yourself, but it's not like it's going to... Water boils at 100 Celsius, and it's only 75. So, Okay, so the first thing I need to do is, let's check the temperature. So this is reading 164. Can you see that? Just turned off. $167. Fahrenheit. So that's in the zone because this thing only gets up to about 175 and then it stops. And then I think the idea is that you have to add a little bit of heat. And that's why I have the heat gun. And I said I want to avoid the microscope if possible because I'm worried that I'm going to reach around and burn myself. Okay, so I'm going to take the pallet fork now this is a spare. It's already missing one pallet stone. So you slip it in there. Now this little handle is what do you call it? It's heat insulated. That's like a piece of some kind of composite material. So you can touch this without burning yourself. And then the lever is not heat insulated, but I think it's not too hot to touch. Okay, so in theory what you would do is you would first measure this. Oh wait, okay, so I'm gonna press down. And then this is also a composite material. So I can push this and we see our meter go over to 31. That's the same place it was in the earlier video I did. And see, when I do this, this meter, this doesn't stop. It's the spring that's causing it to stop. It comes to 31. I can still nudge that, but at that point I'm nudging against the spring. So somehow that spring drive helps with the sensitivity. And then I'm going to have to get the microscope going. It's just too small without it. So get ready for some screaming. So 31. So the idea is I would use this device to set to remove the stone and then reset a new one if that was cracked, for example, in the exact same position. So I'm going to fiddle with that shellac in the condition that it's in right now and see if it's already melted enough to swab it. And I doubt that it is. For one thing, I just put the pallet fork on there. So now this make a little bit of noise. I'll turn this on. Is what I was worried about. Okay, so this thing is already a 216, but now I need a third hand, so I'll try to do this left-handed. And I think that's set to max out. Oh, it's turning off. Oh boy. Yeah, I don't want to overheat, but it's only 216. And I want to get this right down. Let's clean this other side too while we're at it. Okay, so now I think I'm going to have to tweezer that pallet stone out of there. Good luck with that. Okay, so it's inching forward. It's just going to fall inside the machine. So let's see if we can pull this out. I just want to try to nudge that out of there. Okay, there we go. That should not be on. The safety The safety feature of this thing is freaking ridiculous. It's inverted, the logic of it. So it tries to heat up when it's not supposed to, and it won't heat up when it is supposed to. And that is something I bought from a Swiss company selling Chinese-made stuff. Should have returned it. Okay, so now we can imagine let me get a reference pallet fork. This is just to check the angle of that. So this is so this is a larger one, but it's just to be certain about when I put this in there, I want this angle here, like that. So what I'm going to do is now my escapement meter is still hot, so that's why I'm not doing it on there. Like it might actually provide some help if I let it cool down, but seems like not that great to be using metal on the stone. But I don't know how else to get it in there. Deep breath. I saw Kalislav talking about like how important breathing is when you're doing this kind of work, and I was like, that's ridiculous. He's like, don't forget to breathe. And I'm like, who would ever forget to breathe? Now, one of the reasons I'm interested in doing this is that I've always been from the beginning of this watchmaking thing, I'm really interested in kind of the things that I perceive as being the most crazy about watchmaking. So like pallet stones is one of those things. Another is the impulse jewel, because it's also shellacked in place. Damn it. Now it looks to me like that stone is actually tapered a little bit. I have this special kind of tweezer that might be better. Not tweezer, but is that way too big? This is risky. Okay, that's not going to help. I'm too shaky. I need to be lower down with better arm support. I know people will make all these comments. But again, the truth is, I just want to have a sense of how difficult this is. And then you start to realize, okay, if you had a better prepared workspace, the right tools, if you knew what you were doing, yikes. Oh, so actually, so that's good enough in theory, because I just want to show you. So I've got the angle correct, matching the red one. Now that's started well enough that I can put it back in the escapement meter. It's upside down relative to the way that the shellac goes on the other side. Let me try to fix that without knocking that out. Okay. Then I'm going to bring this back in. Ah. Microscope. So I'm going to try to use the meter to actually press it in place, because that's actually what we want to do. We want to start further out and then press it to 31. Now this thing is still hot. It's actually hotter than ever. Okay, now this has two things. One is it'll press it. See, right now we're at 57. And then, like I said, the spring stops it. But you can push beyond that, and then it starts to push the actual jewel. So I'm hand pushing it in. I'm going to try to stop at 31. Nice. I pulled it back. That's why it shot back like that. Okay, so that's that. Now, I need to shellac it in that position. This is so ridiculous. So these little things of shellac, it looks like nothing, but look at how they're actually gigantic compared to what I need. I already looked at this. So if I pull out, I visited the shop of this guy Pascal in La Chaux-de-Fonds. Actually, it's been a couple months now, but he had like a chunk of shellac that was the size of like a gold bullion bar, like that doesn't mean like a kilo, and it was from the 1950s. And he was like, "Yeah, they don't make it like that anymore." And I was like, "Geez, that's such a huge piece. What do you have?" Oops, that was a little bit too small. I hope that this gives you guys an idea of something. I don't know. Like, obviously, one could be, if you did this all your life, you know, you get good at this. But my point is with these tools is that this is actually kind of not that far from what. See, now I got way too much. It's not that different from what they did back in the day. And they're still doing it, some traditional watchmakers. That's like twice as much as I need. So let's do this. Let's see what the temperature is right now. I got to take that off though. I can't, if I overdo it like that. Oh, it's 201, so that's risky. It might start melting it. Yeah, it's starting to melt. Well, let's see what happens. Maybe I can remove, I think I can remove what I don't need after it starts to melt a bit. Gotta be careful not to just grab this thing. Okay, I'm gonna have to remove some material here. Still twice as much as I need. Yikes. Okay. Now I can just let it sit because we know it's at 210. It should melt down, but I could also hit it with the heat gun. Now what happened? Okay, that's still too much shellac. Oh. Okay. So now I'm going to unplug the escapement meter. And I'm going to unplug the heat gun for sound. Escapement meter's still warm, but basically all I want to do is check the distance again now that it's, I mean, it's still hot. I just want to check it. But I have to be careful not to, okay, so it's, just want to check a couple things here. One is that I need to make sure that the back of the pallet fork is against the measuring device for my reading to be correct. But then also when I push it with this, it will go, oh, there we go. Oh, I went at half of a, I think it's coming back though. Okay, the other thing I want to do is kind of, you got to make sure it's flat. Let's do this again. Okay, we're back at 31. So that's it. I would let that cool down in the escapement meter. And then that would have been how you replace and reset a pallet jewel at the same position. The thing is, you have to know what the position that you're going for is. Well, one thing I was thinking actually, if you're doing a repair on a watch, you don't have a sample to compare it with. You could do this over and over again in the movement, because once you put the pallet fork in the movement, you could look at it and go, okay, the stone is needs to be a little bit further in or further out. And you could look at it and see if it's a hundredth of a millimeter is kind of crazy, but I think you could actually see which direction it needs to go, and then you can use the gauge on this thing to move it in that direction. The problem is if you go too far, how you pull it back out with hot shellac, poking the back of the pallet stone like I did to get it out in the first place, it seems kind of sketchy. But I think that's how it's done. I think that's it for this thing. So I just want to do that follow-up with more depth. I feel a little bit embarrassed that I'm not more of an expert. That's why the silent videos work better for me. Don't have to admit how stupid I am or how little I know. But anyway, that's it. This thing's really cool. So I can grab it by the insulated holder here. It has these rubber feet on the bottom, specifically so that when it's hot, you can move it to some other surface and it won't melt it. And the other thing is it came with some instructions. So you can see the temperature, the handling piece there. Don't remember if this is in English. French, German, French, German. So the other thing is, when I was painting the heater, it didn't work when I got it. So I opened it up. It's very simple. There's a plate that's got like a material with each of the AC power cables just going directly to it. And then it's got a couple of plates sandwiched with some insulator kind of screwed up to the top of the plate right here. But the point is, this thing is exactly the width so that it's those rubber feet on this straddle the top surface of this. So if you were going to use a conventional hot plate that was too big to do this, you would have to put a piece of copper or something that's very heat conductive on top, that like a bar that's the fits between those rubber feet to get your heat up to the bottom of this. Because if on a larger hot plate, the rubber feet would hold it above and then it would be insulated from the heating surface. So that's a good thing about the actual original one. And then the other thing is, if you had any kind of hot plate that was oversized, you're in a worse situation in terms of potentially burning yourself. Because the heat element is really just the size of the back of that, and it's located right here. So I think that's it. Thanks for watching. Oh, if you want to watch the video, the silent video about this, where I used it to measure and compare real pallet forks for a Felsa F760 watch I'm working on, that link should be one of the links that you see on the screen there. Thanks a lot.